Hello students, today is our final session on chemical changes and reactions.
Let's begin with alloying. What is alloying? It is mixing of metal with another metal or a non-metal to improve its properties. The mixture thus formed is called an alloy. Like iron is mixed with carbon, which forms stainless steel, which improves its rust resistance. Pure iron gets rusted, but stainless steel is rust resistance. Then pure gold is soft and cannot be made into jewelry, but silver and other metals are mixed to make it workable. You might have heard people saying 24 karat gold. Now this tells how much pure gold is. 24 karat gold is pure form, but the jewelry is made in 23 or 22, so that the jewelry is not soft. Then silver amalgam is alloy of silver and mercury. It is used in dental fillings. I'll show you the procedure how we make the silver amalgam. Amalgam is an alloy which contains mercury. See. This is mercury. On this we add some silver powder. And then we mix it. Now you can see this silver deposits. If I have taken this in large amount, then I would have got more of the amalgam, but I don't want to waste the material, so this is silver amalgam that is formed. The mercury is consumed in this process. Our next topic is displacement reaction. In some reactions, more reactive metal replaces or displaces another or less reactive metal in its solution. For example, reaction between iron and copper sulfate. What happens if we prepare the solution of copper sulfate and dip an iron nail in it? It changes to the copper sulfate is blue in color. It changes to iron sulfate, which is green in color. Let me show you how the change occurs. See this picture. This is copper sulfate solution. This is copper sulfate and iron nail is dipped in it. What happens? After a few hours, the color changes to green, and you can see this redness in the bottom of the beaker. This is due to the precipitation of copper. This copper from the solution is removed and iron takes place, thus it takes its place. Thus the reaction is displacement reaction, and the color changes from blue to green, and the copper deposits over the iron nail. Now what will happen if we take iron sulfate solution and dip a copper wire in it? Just opposite of it. In this we took copper sulfate and dipped iron nail. But what will happen if we insert a copper wire in this green solution? Nothing, because iron is more reactive than copper, so copper cannot be displaced from, so copper cannot displace it from its solution. Thus, we can infer that a more reactive element can displace less reactive metal from their compounds or aqueous solution. Aqueous solutions are solution of anything in water. Based on this relative reactivity of the metals can be arranged in a series from more reactive to less reactive. This series is known as reactivity series. It is given in your book. You have to learn this series, most reactive to least reactive, and reactivity decreases as we move down the series. Potassium is the most reactive and gold is the least reactive known metal. The above reaction which I showed you was the single displacement reaction. But neutralization reaction, the reaction which I showed you earlier, that was between vinegar and sodium bicarbonate, or the precipitation reaction, are double displacement reactions. In these two radicals are exchanged. Like this reaction which we just saw between iron and copper sulfate, iron displaces copper from its solution and forms iron sulfate, and copper is removed. In this, only one exchange has occurred. Now see this reaction. These are both neutralization reaction, the acid-base reactions I have told you. In this, sodium hydroxide reacts with hydrochloric acid and forms sodium chloride and water. What happens? Na and OH breaks. In this, H and Cl breaks. This Na combines with chlorine, sodium combines with chlorine, and OH combines with H to form sodium chloride and water. Thus, two radicals are replaced and two things are formed. Another example, vinegar and sodium bicarbonate. A salt is formed, water is formed, and carbon dioxide is released. In this precipitation reaction, silver nitrate reacts with potassium nitrate, potassium iodide, it changes to potassium nitrate and silver iodide, which is precipitated as yellow precipitates. This is the precipitation reaction, but an example of double displacement reaction. See, Ag displaces potassium and NO3 and Ag displaces potassium and combines with iodine, and potassium combines with nitrate. What will happen when we mix sodium sulfate and barium chloride? This is sodium sulfate, this is barium chloride. What forms is sodium chloride and barium sulfate. This is also a double displacement reaction. Then comes the decomposition reaction. In decomposition reaction, a single reactant breaks down to give product. Decomposition occurs when the reactant is heated or electricity is passed through it. For example, we take iron sulfate, we heat the iron sulfate, it changes to ferric oxide, sulfur dioxide and sulfur trioxide are given out. These two gases smell like burning sulfur, or they smell like when you light the matchstick, it gives a particular smell. The sulfur dioxide and sulfur trioxide smell like a burning matchstick. Now our next topic is, how do we separate solid from solution? There are two procedures to separate the solids from solution. The one is evaporation and other is crystallization. Both of these are physical changes. In this process, the water is changed into water vapors. It is given, it's just a simple procedure, like we prepare a solution and then we heat it. The solid is left behind and the water is evaporated. This procedure is used to obtain salt. Now you know the sea is source of a number of salts. Now how we obtain salt from seawater? Like here it is shown in this picture, shallow pits are formed and water is left over. It is allowed to evaporate. The sunlight heats the water and water gets evaporated, and then this salt is collected. This is how we extract salt from seawater. Now this salt which is formed here is not pure. It contains other impurities also. There are many other procedures to purify this. Now crystallization is one of the process which is used for purification of the salts. The crystals obtained from evaporation are not pure. Large crystals of pure substances can be formed by using the process of crystallization. There is an activity given in your book to form the crystals of boric acid or borax. For this, what we use is boric acid. It is white powder substance like this. What I have done is I have prepared some crystals for you people. Just see them. Now what I have done is I have taken half the glass of water. Half glass of water. I warmed it. Then I mixed boric acid in it and food color. Now you see these shiny deposits. I've left it overnight and this crystallization has occurred. This is very simple and easily it can be done at your home. Now you can see the boric acid crystals on the thread also. See these yellow orange crystals formed here. Now for the last topic for the chapter is, can we dissolve any amount of a substance in water? Before coming to the topic, I'll tell you what a solution is. Solution contains two parts, solute and solvent. Solute may be solid or liquid and solvent is usually a liquid. So these two are mixed to give a solution. Suppose we take 100 ml of water and then we add 5 milligram of salt in it. It gets dissolved. We add another 5 milligram, it again dissolves. Such a solution which has a capability of dissolving more solute is known as an unsaturated solution. But when I further add some salt to it, it settles at the bottom of beaker. This solution where no more solute can be added to the solution at room temperature. This is the condition where the solution is said to be saturated solution. Then what I do is I heat that and I add 5 milligrams of salt, it dissolves. But after adding some more salt, it does not dissolve it further and it starts to settle at the bottom. Such a solution is known as supersaturated solution. We use this solution for crystallization or evaporation also. More the saturated solution is, more easily both processes will be happening. When this salt or the sugar or any solute precipitate out of a supersaturated solution, it changes to saturated solution.
With this, we finish the chapter. Book pages and in between questions plus back exercise will be uploaded on the school website. Thank you.